All right. Last time we understand to find the GCF and the LCM. On lesson 1.3, we will solve the LCM and the GCF in one word problem. So this means we're going to find the GCF and so this means we're going to find the GCF and the LCM in one word problem. So we are going to look at this long word problem. We're going to identify the GCF and the LCM. So this is a big story problem. There's going to be one down here I forgot to add, but I forgot to add it. Pretty cool. Love it. They don't. I was like, I forget stuff. Just I'll make sure I add it the next time. Because now it's in a rush. So, now let's look at this. Solve unknown problems involving the GCF and LCM. When you look at a lesson, you always have to look. You always have to look at its title because sometimes you have to know what you're looking for. You can't just solve a problem without looking at its title. Imagine you're looking at like you're solving a lesson and saying find equivalent ratios, and you didn't even see the title. You're just like you don't even know what it is. You just start solving the problem and you get it wrong. The reason is because you're not looking at the lesson. So you have to break down the lesson. Solving unknown problems with the GCF and LCM means we're gonna solve some problems with the GCF and LCM in the same word problem. If you're finding equivalent ratios, you're gonna find the same ratios but just different values, right? Different same value actually, it's actually same value, different equivalent. So you have to look at you have to look at the word problem because you can't just say this is how it's supposed to be. Even if you're going to get it wrong if you don't look at the title. First, second of all, you have to read the problem at least twice time because if you don't read the problem, since I'm an advanced person, I can only read the problem once to solve it. But since if you learn a new topic, you actually have to understand the problem twice or two times. So if it's a long problem, you can just read it once, but you have to identify this. Maria has two different sets of beads for her crafting projects. The first set contains 24 red beads, and the second set contains 36 blue beads. She wants to create a necklace using both types of beads. The GCF. Now let's get to some key words we're seeing. We're seeing the GCF and we're seeing the LCM. We're seeing two different things. She wants to know the largest number of the identical bracelets she can make using all of the beads without having any beads left over. What is the greatest number of identical beads that she can create? Now we'll look at the LCM. After making the necklaces, Maria plans to bead all the bracelets with her friends. If she wants to make a bead using all the red and blue beads, how many beads will she need to make sure both types of beads are used up completely in each bracelet? What is the least number of bracelets? The least number of beads she will need to she will need for each bracelet. Here's a problem we're trying to identify. Here we're trying to identify what's the least number of beads that she will need for each bracelet. We're trying all to identify that she is the problem's about. It's called the main ideas. The main idea is basically what the entire problem's about. In this passage, that she wants to make beads. She's planning to make beads bracelets with her friend. That's the problem. This entire problem about the main idea. Now, if she uses the same beads using all red and blue beads, how many beads would she make? To make sure, basically just the whole passage is highlighted. In LGCS, she wants to know what's the largest identical beads she can make using all the beads without having any beads left over. So basically, we're just finding the GCF. So highlight the entire problem too. She has two different sets of beads as well for crafting projects. The first set contains 24 beads. The second set contains 36 blue beads. Right? She wants to create a necklace using both types of beads. We have to highlight a lot of stuff. Sometimes if it probably gives you too much information, you don't have to highlight everything. I had to highlight everything here. I had to highlight everything. That's because you don't have to highlight everything. We can just if everything's important, you don't have to highlight it because everything's pretend you can pretend to highlight everything because everything's important, right? All right, so we're gonna find the GCF first. So first, we're gonna have to do is gonna find the GCF. What am I doing? We're gonna find the GCF of the first 36 and 24. So first, we're gonna use 24, And then we're also going to list 36. Um, all right, we've already know that 1 times 24 is equals 24, of course. 2 times 12, of course, equals 24. 3 times 8. Then 4 times 6. So 5, 6. That's it. Now I'm going to have to do this one. 1 times 36 is equal to 36. 2 times 18 is equal to 36. Oh, there's a big multiplication sign. 3 times 12. 4 times 9. And then we got 6 times 6. All right, next we're going to circle the common factors. So the common factors are the same factors between two numbers. So here's 1. Here's another. They're both odd. If they're both even, the two can be common factor. Uh, 3. If the sum of the digits add and is divisible by 3, the common factor will also be 3. 4. If you can divide this by 2 twice, it will be divisible by 4, and it becomes factor 4. 6. It has to be divided by 2 and 3 to be with 6. Next, we're gonna find the common. Now scenario have the common factors, but GCF find first. We're gonna have to find the CF or the GCF. 1, 2, 3. They got 4. And they got 6 as well. Cause 6, these cell 6 is like multiplying like by itself. It doesn't matter. Just put 1 6. It's fine. Now the GCF would be the GCF equals 6. How about um how about the LCM? The LCM. So now we're gonna list the common the multiples. You can use a calculator for this. So right here I'm gonna use a calculator. I already know that 36 goes 1 first. And if I multiply 36 times 2, well, 36 times 2, 72. I use a calculator, I'm just doing it in my head. Then 36 times 3, 72 plus 36, 108. So we can keep going after that using a calculator. So I'm going to show you how to use a calculator for this. So you got 24. I know 24 is 48, 9, and then going to be 6. All right, let's now look at the multiply 4. So there's a calculator here. There's a calculator. Take a Y now. Calculator. In my Spanish version, there's none of my Spanish. 24 times 4 is 96, so that's already good. What? 72, I forgot. So let's look at 24 times 3. 72, I forgot that. 72, then 96. 36 times 3, 108. 36 times 4, 144. I think 12 times 12 is pretty good. I'm going to keep going until we find a common factor. So 24 times 5 equals 120. Then 36 times 5. Let's see, 36 times 6. 36 times 4. 6 times 5. Alright, 180. So I already know that there's 1, 2, 3, 4, 5. So I'm going to multiply this by 6 next. That gives 144. There we go. Find a common factor easily. 144. So we always have to use a calculator, right, to find the multiples. Multiply 2 from 24 to 1, and then ending until you see a multiple. See, here we multiply 1, multiply 2. See, here we multiply 3. Here we multiply 4. Here we multiply 5. We have to keep multiplying and listing them down. So the first we see is 144 here. And then we're going to already know the LCM is just one number, or 144. So, I love using this voice. Okay, alright, so now, so basically, now is our GCF and LCM. I want you to try to find the GCF and the LCM of, let's say no, I'm gonna do this. How we find the GCF and the LCM, find both. Oh my gosh, what are my arrows? Of 56 and 28. Alright, have a good time.